Hello everyone, this is Group 1. Our topic is cybersecurity in Android smartphones. The technology of mobile devices is generally improving and smartphones are becoming an important part of everyday life. By 2021, the number of people using smartphones will have risen from 2.5 million in 2016 to 3.8 billion, and will continue to increase year on year. Smartphones are available with various operating systems such as Android, iOS, Cyberns, and Windows. In 2020, Android will account for nearly 80% of market share of all operating systems. Mobile devices have become necessary for everyday use, and a wide range of applications such as online shopping, information access, and EID are being used on mobile devices. The sheer volume of mobile devices used to make life easier and has created a huge cybersecurity risk. And cybersecurity attacks are on the rise. Compared to iOS, the number of vulnerabilities in Android is increasing year by year and surpassed than the iOS, which shows that Android is currently facing huge cyber attacks and security threats. Now let's move to the text 1.
Hello everyone, my name is Yuchen Liu. Now I'm going to introduce the first attack of our research project. This attack is man-in-the-middle attack. So to further specify man-in-the-middle attack, I'm going to use 3 different questions to address this attack. So the first question is, what is the man-in-the-middle attack? So man-in-the-middle attack can be considered as a cybersecurity attack where the correspondence and message exchange between 2 parties are secretly changed and intercepted by malicious actors. The second question is, what is the aim of man-in-the-middle attack? So man-in-the-middle attack aims to steal and gather individual private information such as account number, login certifications, or even credit card numbers from users. And the third question is how man-in-the-middle attack works. In order to explain the answer of this question, I'm going to use the next slides. As you can see from this figure, you can see man-in-the-middle attack is intervene between the connection between users and web applications, try to eavesdrop the message exchange between these 2 parties. And next slide is the man-in-the-middle attack in a network typology. As you can see, an actor intervene between clients and gateways. So like every external network message from internet can be eavesdrop or by intercept by this protector before the informations arrive clients. Yeah, and next slide, I'm going to talk about man-in-the-middle attack progression. This progression consists of 2 parts, which are interception and decryption. And in the concept of interceptions, there are various strategies to achieve interception. So the first one is IP spoofing, and the second one is ARP spoofing, and the third one is DNS spoofing. And according to description parts, there are 2 different strategies to achieve this one. So the first one is HTTPS spoofing, and the second one is SSL hijacking. Yeah, and now is the main part of my presentation. So after introducing lots of different concepts about man-in-the-middle attack. So how can we prevent this attack? So I proposed to, I also reviewed lots of research, and I proposed to methods which is quite effective. The first one is server certificate pinning. So I think it is defined as like this method defined as a cybersecurity mechanism that client knows exactly which server certificate is exclusively required for secure connection. And the second method that I think is quite effective to prevent man-in-the-middle attack is client certificate pinning. It's quite similar to the first one, but client certificate pinning involves the issuance of unique certificates which must be pinned to each client with a matching unique private key. Yeah, these two have some similarity. However, they are still have some difference. Yeah, and this is my presentation. I'm going to pass to my teammates. Thank you very much.
On the technological advanced, some ransomware now combine both functions, such as double local ransomware, which appeared in 2017, which can not only deny user access to other functions of the Android mobile, but also encrypt the data, forcing user to choose between paying the ransom or losing their data. Because the Android operating system is open source, users can obtain the installation package for applications from any website. Although this feature provides Android operating system user with greater freedom and customization, the network is also inundated with numerous fake and malicious programs. Also, most Android devices include reputable app store. Some user may need to download the application from the website because users may be unable to find the app they require in App Store. For example, like the Android user in China, they can't download VPN application. So when we download some application on the website, hackers may have injected malicious code into these unknown source apps. When a user downloads software containing malicious code from a certain website, the malware will typically request various permission on the from the user, such as the system notification permissions or the permission about access related data. After the user grants these permissions to ransomware, the ransomware will encrypt the user's data using encryption algorithm or lock users' Android devices via the notification bar to prevent the user from performing other operations. Typically, at this point, a message from the hacker, such as like the payment methods, will appear on the user's device. This image shows the ransomware attack process on the Android platform. Ransomware typically requests special permissions to complete an attack, but most Android users rarely refuse the request for various permissions because most Android software will also ask for them. When the application is installed, such as like camera, microphone, and album permissions, this situation significantly reduces the vigilance that ransomware will request privileged access. It is more effective to take appropriate precautions against ransomware before it causes harm to Android devices. One of the most effective way to avoid malware is to only download apps from official app stores, such as Google Play. And the application in these app stores are typically reviewed to ensure no malicious code is present. This method can significantly reduce the likelihood of downloading the ransomware. Backing up personal data is another excellent way to mitigate the effects of ransomware encryption. A user can safely remove ransomware by resetting the devices, and they don't need to worry about losing important data if they have already backed up their data to like a local storage device on the cloud. The last critical security measure will be to keep Android updated. Users will receive security patches in the most recent system update, which used to address potential vulnerabilities. Okay, let's welcome another person. Thank you. Ransomware typically requires special permissions to complete an attack, but most Android users rarely refuse the request for various permissions because most Android software will also ask for them when the application is installed, such as like camera, microphone, and album permissions. This situation significantly reduces the unwillingness that ransomware will request unprivileged access. It is more effective to take appropriate precautions against ransomware before it causes harm to Android devices. One of the most effective ways to avoid malware is to only download apps from official app store, such as like Google Play. And the application in this app store are typically reviewed to ensure no malicious code is present. This method can significantly reduce the likelihood of downloading ransomware. Backing up personal data is another excellent way to mitigate the effects of ransomware encryption. User can safely remove ransomware by restarting the device, and they don't need to worry about losing important field if they have backed up their data to local storage devices on the cloud. The last critical security measure will be to keep Android system updated. Users will receive security patches in the most recent system updates, which used to address potential vulnerabilities. Okay, that's all of my part. Thank you.
This is Yijun, and I'll be introducing the WebView vulnerability attack. I will firstly talk about what is WebView so that we can have a brief understanding of it and why it would be vulnerable. Then I will talk about some common WebView vulnerabilities. And lastly, I will talk about how to prevent WebView vulnerability attack. So, WebView is a component based on the WebKit engine, which has the function of rendering web pages in the application. It is flexible because you can directly modify the web page code to realize page changes without upgrading the client. For example, if you want to achieve a different pages open at Halloween and Christmas, you can use WebView. WebView has been used in most social applications. If you ever open a web page in WhatsApp, Twitter, or other applications, that means you've been getting in touch with WebView. Thus, it is one of the most widely used components in the Android ecosystem. WebView is vulnerable because WebView objects use binding interfaces, which will not prevent JavaScript code from accessing private data and system resources on a mobile platform. As a result, it will break the security model used in independent browser to enable the interaction between JavaScript code and the underlying system. Normally, there are three common security vulnerabilities, namely remote code execution vulnerability, password plain text storage vulnerability, and less control vulnerability. To begin with the remote code execution vulnerability, the first remote code execution vulnerability is the add JavaScript interface. This interface allows attackers to add JavaScript bridge interface to WebView, and JavaScript can directly interact with the local Java interface by calling this interface. Then it comes with security problems, such as the Trojan horse program installed, sending short message with deduction, an address book and messages being stolen, and the files in the SD card of the local device being obtained, resulting in information leakage and even the remote control of the mobile phone. When the original JavaScript gets the Android object through the Java reflection mechanism, it can call all the methods in the Android object, including the system class, runtime class, so as to execute any code. The get class of the object in Android can get the current class, and the full name of the current class can load the Java lang runtime class to get the runtime class, which can execute local commands. Another problem of the remote execution is caused by the WebView built-in exported interfaces. They are the search box Java Bridge interface and built-in exported accessibility and accessibility traversal interfaces. Apps that call these three interfaces will face remote code execution vulnerability on Android system that opens the third-party service in accessibility options. Next is the plain text storage vulnerability. So WebView turns on web password saving functions by default. After this function is turned on, when the user inputs the password, a prompt box will pop up asking the user whether to save the password. If yes is selected, the password will be protected in plain text in the WebView docs database. So there is a great danger that the password will be stolen since it is not encrypted. The last vulnerability is the last control vulnerability. So because WebView can use the file protocol by default, which means there is a potential that application A can use the activity exported by application B to make application B load the URL of a malicious file protocol, so as to obtain the internal private files of application B, thus threatening data leakage. So, in order to prevent vulnerabilities attack, if you must use the add JavaScript interface, you may take the following action. For Android 4.2 or above, the methods that are allowed to be called by JavaScript must be annotated with JavaScript interface, so as to avoid vulnerability attacks. For apps that are under Android 4.2, we can use set web Chrome client reused on JavaScript prompt to intercept prompt message for interaction. And we can use WebView.remove JavaScript interface stream name method to remove search box Java bridge, accessibility traversal when creating WebView. As for the plain text storage vulnerability, we can turn off the password saving functions through the code websetting.setSavePassword files to prevent local embedment of plain text passwords. And lastly, to prevent lax control problem, For applications that do not need to use the file protocol, we can disable the file protocol by using the code setAllowFileAccessFile and only allow the file protocol to load JavaScript for the application that need to use the file protocol. And next, I will pass to our next member.
Now, let me present the privilege escalation attacks. Android operating system architecture is divided into Linux kernel layer, an intermediate layer, and an application layer. To protect the user's private data and system data from attackers or other malicious softwares, Android has a sandboxing framework. The sandbox illustrates that each application so that it cannot access other applications' data or system data. Applications can only access themselves and the file they have access to. However, Android's sandbox model does not completely prevent privilege escalation attacks. As shown in diagram, application A, B, C are isolated in the three sandbox, which only application B have B1 access. However, neither CB1 nor CB2 are protected by any privilege labels, so any applications can access them. A1 can access CA2, CB1 can access CC1, which is protected by P1 privilege. And the CA1 cannot access CC1 directly, but CA1 can access CC1 via CB1, which is a form of application level privilege escalation attacks. The privilege escalation attacks can be divided into application level and kernel level. Kernel level privilege escalation attacks generally exploit vulnerabilities and flaws in the system's kernel, allow the attacker to evaluate their privilege to the highest super-admin level and subsequent gain control of systems, collect system and user data, and install malicious software on the system to access the user privacy data at any time. Application level privilege escalation attacks are typically performed between multiple applications to obtain software operation and control privilege and the data field privilege. As shown in figure, Zoom et al. Divided the application level privilege escalation attacks into two main categories, namely application software mechanism exploitation and cooperation between applications. Application software mechanism exploitation is further divided into confusion attacks as well as collusion attacks. A confusion attack is when an attacker exploits a vulnerability in an application software to make the application perform a malicious operation and employ it to other applications. A coercion application attack is when two machine application use software, system, and hardware to communicate and send their data to each other and then to attacker, compromising the user's data. Cooperation between applications is when multiple applications use code or data to cooperate, allowing the less privileged application to access the data of more privileged application and gain access to the user private information. The way of attacking privilege escalation is user password safe. Social engineering attacks like phishing or domain name solving, system misconfiguration, system vulnerability exploitation, machine learning, malicious software attacks. To prevent the advance is that the user should not use the weak password and the same password with other applications. Do not install the untrusted software developers need to set software permissions to the minimum and always check for the vulnerabilities and fix them. That's all. Thank you.
Now, let me give a brief summary to conclude today's presentation. In order to help students understand the security challenges of Android platform, this presentation discusses in detail 4 security problems in the real world and possible solutions according to these attacks. We presented man-in-the-middle attack, ransomware, web vulnerability attack, privilege escalation attack, and potential prevention measures. Generally, upgrading system regularly and only downloading softwares from reputable platforms can effectively reduce the risk of being attacked. With the continuous popularization and development of mobile phones, it is more than important for people to pay attention to the security of mobile platforms, especially for an open source operating system like Android. That's the end of our presentation. Thank you for listening, and this is our reference list.